So in the previous video, we looked at the natural log and differentiation. Now we're going to look at natural log and integration, and in particular, we're going to look at the log rule for integration. So in the previous homework, the last video that we did together, we proved that if we took the derivative of the natural log of an absolute value of u, where u is just some function of x, that we get the form u prime over u, which I was calling the form crap prime over crap, or I indicated when you take the derivative of the natural log of the absolute value of u, you get 1 over crap times crap prime. So we're going to be looking for, when we're integrating, we're going to be looking for this u prime over u form showing up, and that tells us if we're integrating that we're going to use a natural logarithm. So if I take what we did in the last video, the d dx, the derivative of the natural log of the absolute value of u, where u is just some function of x, and we know that that's equal to u prime over u, then we can ask ourselves, what happens if we integrate both sides of this with respect to x? And we know that the antiderivative is going to work as the inverse of the derivative, so they're going to cancel each other out and just give us the natural logarithm back. So we get the natural log of the absolute value of u equaling u prime over u. And then what we have to remember when we, equaling the antiderivative of u prime over u. And when we integrate, we want to recognize or remember that we get a family of antiderivatives, or a family of functions, so we always have to add on that plus c. So if we're integrating something that has the form u prime over u, we're going to get the natural log of the absolute value of u plus that constant of integration. And in this case, this is just a special case. If instead of putting the u in here, if we just let our function of x be x itself, well, we know that u prime, the derivative of u, if u is equal to x, then u prime is just 1. So 1 over x has the form u prime over u. It's just a special case where the function is the function u equals x. So if we take d dx of the natural log of the absolute value of just x, we know that that's equal to 1 over x. It has that form u prime over u. And so when we integrate this with respect to x, we're going to get the antiderivative cancels the derivative, and we're going to get the natural log of the absolute value of x plus some constant of integration equaling the antiderivative of 1 over x dx. And that's summarized right here at the bottom of the page. And so on the next page, we'll just show the simplest possible case where this can show up. And then in subsequent videos, we'll do increasingly more difficult or more complex examples of integrals that wind up yielding the natural log function. So in this case, I have the integral of 4 over x dx. And what I want to recognize immediately is that the 4 in the denominator position is a constant, so it can factor out in front of the summation or the integral, which will leave behind the 1 over x dx. And I'm going to do this kind of in a non-standard way initially, and we'll talk through this. So this is going to equal, here I have 4 times, and when we integrate 1 over x dx, we know that we just get the natural log of the absolute value of x plus that constant of integration. I'm going to call it constant 1. And then I could distribute my 4 into that parentheses. So I'm going to get 4 times the natural log of the absolute value of x plus 4 times constant 1. But 4 times the constant is just going to yield another constant. So I'm going to get 4 times the natural log of the absolute value of x plus some other constant. So in this case, this would be an uncommon way to walk through this process. So usually what you would do is recognize that you're going to get the natural log of x plus a constant, and you know you're going to be multiplying 4 by the constant, which will just give you a constant. So what would be more common would be to jump from the antiderivative here to 4 times, I know the antiderivative of 1 over x is the natural log of the absolute value of x. and then plus a constant of integration. I know I would distribute the 4 into that constant, but 4 times a constant is just another constant. So this would be the more common way to deal with it. And then log rules, so we want to remember that we have the rule that if we have a times the log of stuff, that this is the same as the natural log of stuff to the a power. So we can bring the coefficient on the natural log into the parentheses and attach it as an exponent to whatever the stuff is on the inside. So this can actually be rewritten here as the natural log parentheses of the absolute value of x raised to the 4th power plus a constant of integration. And then I can take this one step forward, because we know when we raise something to an even power, as long as it's a real number that we're raising to the even power, we know that we don't get a negative out of it. In other words, the absolute value of x, if x is a real number, then the absolute value of x to the 4th power is always going to be positive. In fact, x to the 4th power will always be positive. So this is a case where I am actually able to drop the absolute value symbol off, because the absolute value symbol will make whatever your input for x is positive, and then you'll raise that positive number to the 4th power. But here you're raising a number to the 4th power, which will make it positive kind of by default. So if we had changed this problem a little bit, if this had been a 3 instead of a 4, when we got here we would be to the 3rd power, and the absolute value of x to the 3rd power, well, raising something to the 3rd power, if it's negative, it will stay negative. So we would have needed to keep the absolute value sign on had it been to the 3rd power. So just something to recognize: if we are raising the absolute value sign to an even power, we're going to be able to drop the absolute value symbol off, because we're guaranteed that this number is going to be positive, and we only want non-negative numbers input into the natural log function.